Hello and welcome to another episode of Geography Made Easy. In these videos, we try to make difficult geographical topics easy. In today's topic, we will be discussing a part which is usually taught in practical geography or in a part which is called cartography. We will be talking about scales. This topic is useful not just for students of the CBSE and ISC class 12 board examinations where they have this particular topic for their viva or practicals, but this particular topic or video will be useful even for students who are doing geography at their undergraduate level as well as basic UPSC. Scales is a very important component or topic in geography. Without having an understanding of scales, it is not possible to understand a lot of theoretical theories as well as discussions in geography. Firstly, we would like to look at the definition of scale. What is the meaning of scale? A scale is the ratio between the distance of any 2 points on the map and the actual distance of the same points on the ground. Without using the word map, I can also use the word paper. So we have all used a scale from a very young age. We have used a ruler. A scale is exactly that. A scale helps us to measure any two distances we see on paper. The ruler or the scale which we use to draw lines, we can measure. Usually we have a centimeter or an inch ruler. Sometimes we have tapes which are longer, which again help us to measure the distance. So these are also a kind of scale. But in this case, we are talking about geographical scale. The scale which we use to draw anything on paper, that is what we call as the true scale. So, what is a true scale? A true scale is where the map distance is equal to the ground distance. So my map distance or my distance between point A and B, if it is 1 kilometer on the paper, it is also the same when it is or drawn on the ground. But this becomes a very difficult thing to do. Like for example, the example I have shown in this case where we are talking about a 1 kilometer scale. Now getting a paper which is 1 kilometer long is impossible. Now for example, I need to draw the map of the entire West Bengal state or the map of the entire Delhi region or map of India or in that case map of Asia or map of world. I will not be able to get such a big paper, a paper which will cover the entire West Bengal, which I can draw, on which I can draw. Also, it makes no sense because storing or keeping that piece of paper, it's impossible. So in that case, when we need to draw something which is a representation of what is there on the surface of the earth, we use what is known as scale. So this is an example of a scale. For example, 1 centimeter on the map shows 10 kilometer on the ground. Say I have a map which is this, and between point C and point D, the distance I measure with a plain ruler is 1 centimeter. So if I am using this scale to draw this map, distance between C and D on actual ground is 10 kilometers. So if I take a car and I want to travel from town C to town D, I will actually be traveling for 10 kilometers. So I am using this principle to draw the map. So scales are very important, and this scale can change. I can have 1 centimeter to show 100 kilometers, 1 centimeter to show 1000 kilometers, 1 centimeter to show 220 kilometers, or it can be any other unit also. I'm using centimeter, kilometer, I can have inch, mile. So the kind of unit I use in the country in which we live, the scales will accordingly change, the units will be different. Let us move on. So here we have a photograph, and here we can see that this is, we cannot really read this map because this map is not written in English, but it is written in another language, so we can't read it. So we can say we want to measure the distance between Krasno, this is one place, and say Poldarsa. So we have the other language, and below that we have the names written in English. I can very well know that from here I have put my scale ruler, and it is still 8 centimeters. So 7.5 centimeter is the distance between these 2 points. If I know the scale say how much 1 centimeter represents in kilometer, I will be very easily be able to tell you the exact distance between the towns Kraso and Poldarsa. I will be able to then drive my car from point this to the other point very easily. So scale is not a concept which is just there on paper. It is a practically used concept, and this concept is used for drawing all the maps we see on the world. Now comes a very important point. Sometimes a friend asks you that tell me how I will go to your house. Especially when we didn't have Google Maps, we would quickly on a piece of paper just scribble a map and give it to them. So I will tell you this is my house, say Joe's Cafe. I am telling him that okay, come to Joe's Cafe. So I'm Joe, and from the bus stop you walk, you cross a church, and then you go right and you will see Joe's Cafe. Now this map is not a map, and the reason why it is not a map is because there is no scale. So these kinds of maps are called sketches. So when we were children, we have read many books in which we have read about Treasure Island, a pirate's map. Those maps in geography are not really called a map if it is just a scribble, or just a scribble of distances, or it's not true to scale, it's not drawn to scale. As soon as you insert a scale even to this map, then it can be called a map, otherwise it will be called a sketch. So now we will look into the different types of scales. Broadly speaking, we have three types of scales: the statement scale, the representative fraction, commonly known as the RF, and we have the graphical scale. We will be discussing each type and their advantages and disadvantages. I will in this video mostly focus on statement and representative fraction and their conversions, and the graphical scale part, if you want me to show you how to draw graphical scales, you can write to me. You can put a comment in the comment section. Okay, before we start with that, we have another way of classifying scales, which is a large scale map and a small scale map. Let us look at this example here. So what is a large scale map? A large scale map is a scale where more details are shown, and small scale maps where less details are shown. Many of you have used or seen topographical maps. In topographical maps, a small part is shown in large details. We can see the individual villages, we can see the distances. That kind of a map is a large scale map. On the other hand, say I have a map of Kolkata, or I have a map of Delhi NCR region, where I will not be able to say focus or zoom or look into the plan or the map of say Connaught Place if I'm looking at Delhi. So that is a small scale map. Map of India, map of world. Let us look at this example. So we have the map of America here, and we are slowly zooming into Atlanta, and finally we are looking at the Atlanta town. So this is the large scale map. The more we are zooming in, it is the scale is becoming large. The more we are zooming out, the scale is becoming small. This principle is also used with the digital maps, and if you are using Google Maps, it also has a scale, and this scale principle is maintained. If you are zooming in, you will see that the scale changes. You have a scale option bar which you can activate. You will see that the scale changes as you zoom in and the scale changes as you zoom out. So this is the reason, because the detailing is changing as we zoom in and zoom out from a large scale map, from a small scale map to a large scale map. Now let us look at the first type of scale, which is the statement scale. Now what is a statement scale? A statement scale is when we are writing the entire scale in the form of a statement or in the form of a line or in words. For example, if I write 1 centimeter on the map represents 1 kilometer on the ground. When I can write this, this is called a statement scale. Now, what are the advantages of the statement scale? As you can see, very simply, I am stating that 1 centimeter on the map represents 1 kilometer on the ground. So, it is very simple. It is easy to express. We have been able to express it in simple language. Any person can understand what the scale means, and it gives you the correct idea of distances, because it is mentioning that 1 centimeter is representing 1 kilometer. So it is very directly telling you or giving you the correct idea. There is no numbers or any kind of hidden meaning in the scale which needs extra skill of interpretation. What are the disadvantages of this kind of scale? It uses only one kind of measurement. In this scale, we are using kilometer, centimeter. We can use inch, mile. We cannot convert this scale from here. So we need to do mathematical calculations to then find the representative fraction. But if we don't do that, from this scale directly, we cannot get another unit, or we cannot convert the scale into another unit. We need to know the language in which the scale is represented. If I am writing the scale in English and somebody who cannot read English, that person will not be able to understand the scale. For example, if a Chinese person writes the scale in Chinese, I will not be able to understand the scale, or Russian, I will not be able to understand the scale, because I do not know that particular language. The third point is it cannot be reduced and enlarged. In this case, we mean to say that when we draw the scales, we write the scale down on a piece of paper and we go to a photocopy shop and we do reduction or enlargement, or we scan it and we reduce and enlarge the scale, the map. The scale doesn't change, it remains the same. So reduction and enlargement does not affect the scale. Next, we have the representative fraction, or the RF. A lot of people are scared of this kind of scale because it is of numbers. Example is, I'm writing then 1:10. So it is a ratio scale where numbers are used. We have a numerator and a denominator. So we can write this as 1/10, as ratios can be converted. Always the numerator is 1 or unity, and the denominator can be any number. So the advantage of this scale is there is no units. It can be converted into any units. It's a limitless, it's a ratio, it has no units. This is its biggest advantage, and this kind of scale is really it's there in all the maps we see because of its universal appeal of this scale. So but we have to remember, in case of an RF, the left hand side will always be 1. What are the disadvantages this kind of scale? It is difficult to understand if it involves a lot of numbers, and certain people find that difficult. So that is one of the biggest difficulties of RF, and a lot of people are scared because they cannot read the RF. So they will not be able to understand. A layman will not be able to understand what the scale means. When the scale is reduced or enlarged, RF again does not hold true. It doesn't change. So if I'm enlarging or reducing the map, the scale will change. RF will not, I will not be able to do anything with the RF because it's just numbers. So if I'm photocopying and enlarging the map on which it is written 1:10, it is becoming 1:10. The enlargement will have the 1:10 written on it. It will not, actually in reality the scale will not change. So that is the disadvantage in this kind of scale. But because of the fact that it can be easily converted, it has a universal appeal. We'll go into the details when we are converting RF into statement scales. We'll understand it better. The third type is the graphical scale. Graphical scales are of 4 types. We have linear, comparative, diagonal, vernier. Here we will be just little bit showing you linear. I am not going into the details because graphical scales require construction. I'll give you an example. Say I have a statement scale where 1 centimeter represents 2 kilometer. So if I have to graphically represent this, I can draw it in this way. Say this is a 4 centimeter line. Just giving you an example. So I know that this is each is 1 centimeter. 1, 2, 3, 4. So each 1 centimeter will represent 2 kilometer. Usually we write 0 in the middle. 2, 2, 4, 6 kilometers. So what I've done is directly from the statement scale I've drawn this. Now the advantage of this kind of graphical scale is that it is easy to measure and understand as it is a graphical representation. I have converted a scale and drawn, and whenever we are graphically representing a scale, it becomes easier for everybody to understand. So it's a popular scale. And when the map is reduced or enlarged, the enlargement reduction remains true because the graph which we are drawing it, that also will increase or decrease. So with the map, so say if 1 centimeter I had drawn was 2 kilometers and the double enlargement has happened, so now 2 centimeters will be, it has become 2 kilometers. The graph has also to that proportion got enlarged. Disadvantage is we need to know the unit in which the scale is represented. So if you don't know, say we have drawn a graphical scale which is of centimeter, kilometer or mile, inch, we do not know or understand the unit, we will not be able to read that scale. So that problem again we have here. And we need to have the time and we need to have the expertise to draw this scale. So we need to learn how to draw this scale. That is also one of the disadvantages. It is not as easy to understand like or represent like in case of RF or a linear scale. A statement scale. So this is an example of a graphical scale, and we have these divisions. The main divisions are called primary divisions, and one primary divisions is divided into smaller divisions called secondary divisions to give more accuracy to the scale so that we can measure more. Like we have in a ruler, we have say 1 centimeter, then 1 centimeter is again divided into 10 parts to represent the millimeter. If you have a ruler in front of you, you can have a look. Same way, when we draw a graphical scale, we do the same thing to get more fine understandings of the divisions. The division needs to be done. We are not going into the details. If I when I show a video on how to construct a graphical scale, I will show this. Now we will be doing certain sums or conversions from one scale to the other. We will start with conversions of statement scale to RF. So first question given here is convert a statement scale of 1 centimeter representing 2 kilometer into RF. First I will write, when I do the conversion, I will be writing the entire statements down in details, because if I don't do that, it will become very difficult for me. So let me write it down. 1 centimeter on the map represents 2 kilometer on the ground. Okay, therefore for my help, when I'm converting in RF, I know that the left hand side will always be 1:, something unknown. So already in this statement scale, I have been given 1 centimeter representing something. So one part of my headache has gone, has reduced. So I will write next step. Therefore 1 centimeter on the map represents. Now I have centimeter here. I also have to make the kilometer into centimeter, so that because we are making it into a ratio, in a ratio we have both the units which needs to become the same unit, and then only we can cancel out the units. So 1 centimeter on the map represents 2 kilometer. When I am converting into centimeter is so the conversion is, we are using the unitary method to do the sums here. So 1 centimeter is, 1 kilometer is 100,000 centimeter. This is the kilometer centimeter divisions versions which we have the unitary methods and the kilometer centimeter, the CGS and the MKS systems which we have done in school. We are using that. So 1 kilometer is, we know, 1000 meters, and 1 kilometer is 100,000 centimeter. So 1 centimeter, 2 kilometer will be hence 200,000 centimeter. Therefore 1 centimeter on the map represents 2 into 100,000 centimeters. So what happens here is centimeter kind of get cancels. We will not cancel it, but these two will get cancelled. Hence, therefore RF is 1:. Here we are not writing the centimeters because it has got cancelled. So what I have done is, my left hand side is always 1, as I have said. The right hand side was a kilometer unit. I converted the kilometer unit into centimeter, cancelled out the centimeters from both the sides, numerator and denominator, and I got the ratio, which becomes a formless limitless ratio. So from the statement scale I have converted and got my RF. Let us do another sum. Convert a statement scale of 1 inch representing 5 miles into RF. So this is an inch and a mile scale which I will be doing. Again, I will be writing everything down, but before that, let me just write down 1 mile is equal to 63360 inch. We need to know this before we start doing the sum. Let me write 1 inch on the scale represents 5 miles on the ground. Therefore, 1 inch on the scale represents 5 into 63360 inch on the ground. So I've converted the miles into inch. I'm multiplying in this case. So let me see what the value will come. Therefore, 1 inch on the scale represents 316,800 inch on the ground. Therefore, RF is 1:316,800. So this is my RF in this case. I hope this is clear. We'll move on. Now we will be converting a RF to a statement scale. So in the previous two sums, we were converting statement scales into RF. Now we will convert an RF into a statement scale. So converting an RF of 1:50,000 to a statement scale showing kilometers. So again in this case we have a RF which is given. I will be using step by step all the statements in unitary method. I will write down all these steps so that I do not make any mistakes when I am doing the conversion. Let us begin. So 1 centimeter on the scale represents 50,000 centimeter on the ground. So exactly when we were converting into RF, we were making both the sides have the same unit. Here also, so I can put centimeter on both the sides. I can, or if it was an inch mile scale I had to use, I would have been using inch in this case, but it is written centimeter, so I will use the centimeter kilometer scale which go together. So 1 centimeter on the scale represents 50,000 centimeter on the ground. Therefore, 1 centimeter on the scale represents, I want to convert the centimeter into kilometer. So 50,000 divided by 100,000. So this becomes my kilometer on the ground. Therefore, 1 centimeter on the scale represents 0.5 or half, whatever I write, kilometers on the ground. It's better to write in decimal 0.5, or I can write here also. If I want to convert or show this better, this is okay. If I do this here, I get full marks because I am absolutely right. I can also write 2 centimeter on the scale represents 1 kilometer on the ground. Half into half is 1, or 0.5 into 0.5 is 1. So I've made it into 2. Then this of course is double. So it becomes 1 kilometer. I may or may not write. If I write till here, I get full marks in the examination. So if you have any doubts or any questions with what we have discussed, please feel free to comment in the comment section. If you find the video useful, please share it with your friends, and let me know if you want more such videos on scales. So thank you very much.